Welcome everyone. In this talk, I'm going to be providing introduction and context for our panel discussion on catastrophic electricity failure. So looking back to 2023, our NZCAT project found that New Zealand might resist some effects of nuclear war and nuclear winter due to isolation and a moderate climate. Indeed, island geography also probably led to less COVID-19 pandemic deaths. And our previous research has found less impact on islands from past volcanic winters. However, New Zealand is highly vulnerable to shocks that threaten the supply of goods and services, especially liquid fuels and including catastrophic electricity loss. Resilience is needed, and there are strong reasons to over-engineer resilience in islands. It is not only to protect domestic populations, but New Zealand can also feed 8 times its number through food exports if it is allowed to keep functioning. And New Zealand is often cited as a potential refuge for humanity, a place where societal complexity might persist through truly global catastrophes. And so our organisation, Islands for the Future of Humanity, provides analysis and options that could help sustain islands through the worst of times. So what is catastrophic electricity loss? Well, I recently interviewed Dr. Simon Bluin, the lead author of a study modelling US food supply after a catastrophic electricity failure. And he explains in the interview, which you can watch on YouTube at Island Futures, that catastrophic electricity loss can be conceived of as roughly 5% of the world's population or more losing electricity for a month or longer. So these are clearly unprecedented scenarios, but they are possible. We see that compared to an ordinary hours or days long electricity loss, there would be a national or global even, rather than regional impact. There is potentially no external aid that would be coming. There would be a long period of impact such that slow processes like agricultural production might even break down. There would be ongoing degradation of systems through a domino effect, cascading effect, and there may even be the cessation of the inputs required for provision of things like mass relief of food and water. So these are low probability events, but with very high impact, and they're potentially unmanageable without planning and investment beforehand. And several classes of threats could lead to catastrophic electricity loss. These include physical damage to systems, cyber attacks on control systems, disruption to supply of critical components required for maintenance, loss of skilled operators. But importantly, there are 2 very severe threats, those of electromagnetic pulse from a high altitude nuclear weapon detonation or a severe solar storm. And it is worth noting these last 2 potential causes of catastrophic electricity loss because they seem to have the greatest potential for worst case impact. And the risk may actually be increasing due to the 2025 solar activity maximum and the deteriorating geopolitical situation, with UK Prime Minister Keir Starmer even warning yesterday of a new era of insecurity as he increased UK defence spending. So the impact of a solar storm could cause widespread problems with the electrical grid. And acknowledging this potential, New Zealand's National Emergency Management Agency has published a space weather response plan, which specifically states that critical infrastructure may be disrupted for long periods. NEMA's plan, it must be said, is a great start and has also been exercised in August 2024 and will be again in April 2025. And these exercises lead to refinements in the plan. And additionally, NEMA has also just released its Catastrophic Event Handbook. And this hazard agnostic manual includes focus on things like mass relief of food and water or logistics under catastrophe situations, and consideration of lifeline utilities like electricity. However, this Catastrophic Event Handbook does make some assumptions, such as that international aid will arrive eventually. and it assumes a functioning port and a functioning airport. And these may not be the case, depending on the nature of the situation. These need to be ensured. So neither plan extends beyond a short-term recovery phase by design, and also by design, these plans do not detail what might be done ahead of time to optimize infrastructure and resources so that impacts can be prevented or mitigated. The response aspects of these plans assume present resources rather than proposing what investments might help reduce these risks. And our organisation is particularly interested in these upstream solutions, thereby ensuring that well-placed islands are able to ride out global catastrophes. But perhaps the most worrying threat to the electricity system is the electromagnetic pulse from a high-altitude detonation of nuclear weapons. This is because this could lead to instantaneous, continent-spanning impacts on electrical systems. And it would not take many detonations to disable a large proportion of the global electricity supply, while at the same time being harmless to humans. And Stephen Starr doesn't sugarcoat it in his detailed blog description of an EMP attack on the US, where he says that society may suddenly stop working. And importantly, from New Zealand's point of view, a detonation over East Coast cities in Australia aimed at disabling, for example, US military communications, could impact New Zealand. So there are several reports that have been published relevant to catastrophic electricity failure, and I would just like to highlight two of them. One is from the German Office for Technology Assessment, which determined in 2010 that after just a few days, critical infrastructure and services would collapse despite emergency measures, leading to a national crisis. And we can get a flavour of the impact of this sort of crisis when we look at the modelling results from Simon Bluen et al.'s 2024 modelling study, where Simon and his Allfed colleagues found that nationwide disruption of US electricity due to a cyber attack or a nuclear EMP could threaten famine through the effects on food supply chain. And the graph shows both an optimistic green line and a pessimistic grey line return to electricity supply in the top panel, with potential for food consumption to drop by over 50% for many weeks, illustrated in the bottom panel. And so quantification like this is important to get an idea of the scale and resources needed. And we put some questions around these topics and some of these problems to the National Emergency Management Agency, and they, in response, referred us in part to the New Zealand Lifelines Council National Vulnerability Assessment, which illustrates the interdependencies between electricity and other lifeline utilities. And there are dense interdependencies. One example shows that electricity supply is dependent on telecommunications, but telecommunications are dependent on electricity. And so it may be hard to find a pathway to restoring function when these systems go down. And there are essential functions that are not yet listed in these kinds of vulnerability assessments, such as off-road machinery used on farms and data centres. And complementary to this analysis is other research based in New Zealand, and Alana Weir and others have studied the interdependent infrastructure systems in Taranaki, New Zealand, finding that seemingly redundant infrastructure networks are actually highly susceptible to disruption when considering realistic hazard scenarios. So the upshot of all this work is that there is scope for ongoing system redesign. So New Zealand's vulnerability includes issues to do with its isolation and need for supply of maintenance and parts, food distribution, water systems, transaction systems, health services, and communication and coordination, all being dependent on electrical supply. And vulnerability assessments to date generally have not contemplated long-term global disruption for months or years from some of these severe global catastrophes, or have not contemplated New Zealand's connectivity with the world through digital or trade connections. And these vulnerability assessments have focused largely on the robustness of present infrastructure, rather than what doesn't yet exist but could or should. Things like payment systems have been left for future iterations of assessments, and we often don't get quantification of the potential severe impacts. There is also a frequent focus on things like hospitals as the most critical exemplars of services, which underscores the focus on hours or days of loss of electricity, when at a different timescale, perhaps it is agricultural machinery or milking sheds or unloading or loading of ships that become more important. And in our recent blog on our website, islandfutures.earth, we posed a range of basic questions. But importantly, we asked, what consequences are expected from these kinds of major disruptions, and how could investments ahead of time prevent or mitigate these? We also asked what resources or capital stocks would help in the response and recovery. So, to reiterate, catastrophic electricity loss is a common consequence of many large-scale hazards, and it could occur in the absence of other infrastructure damage. The risk may be increasing. An investment is warranted given the huge annualized expected harm, with our own research finding that a majority of New Zealanders support specific plans and even a commission or agency for such extreme risks. And a recent UK study found a significant majority of people favour spending significant resources to prepare for catastrophe. So the public understands this efficiency resilience trade-off. 2025 is no longer business as usual. We need to get agreed solutions now, especially for isolated islands.